Sworn.
And then the
Des Martin.
yeah.
Des Martin is DMP. So let's say Jones, which is Jones. Then Crohn's, no. Crohn's is a disease.
That's a disease.
DCC.
Sworn.
I don't know what sworn is. You got to tell me what is.
No.
Oh wait, no. That's like CO2 and then triethyl something.
CO2.
No.
COCL2. I never heard of that
That's a
before.
parentheses.
Oh, parentheses.
And DMSO. And then you put ethyl. Triethyl. No, that's ethyl.
Triethylamine, yes?
Yeah.
Okay, and this is called
Sworn oxidation.
sworn oxidation. And then after that, what was after that?
Des Martin.
DMP.
Des Martin.
And what if you got an aldehyde and you add this to it? What do you get?
Carboxylic acid.
A carboxylic acid. If you get a second, what did I say?
A secondary.
Well, that's true, but
Then you get a ketone.
if I get a secondary alcohol and I add this, what do I get? A ketone. If I add a primary alcohol and add this to it, what do we get?
An aldehyde.
Aldehyde. And if I have a primary alcohol and I add to this, I get an aldehyde. And if I have one to this, what do I get? Another aldehyde. What cleaves a bond and forms this carbonyl? Cis-diol with what? Periodic acid, right? Periodic.
You said periodic.
Periodic acid. No, I never said periodic acid.
That's what you wrote.
You wrote it
Periodic.
because that's what you're.
You wrote it in this paper. Periodic.
Oh my god, I don't.
Guys, I mean, you do know. You know these, yes?
Yeah.
Yes?
Yeah.
Yes, you don't know these? You've never seen these before?
Yeah.
This is called periodate, yes? So, periodic acid from iodate. And this is iodate, and this is iodide, and this is hypoiodide. Okay, whatever. Reducing agents. Which one are the reducing agents?
NaBrH4.
Reducing agents, the first one I showed you was H2 on palladium. And then?
Sodium borohydride.
Sodium borohydride, which can be used in water and is mild, yes?
Yes.
It does not do all reductions. And then there was the bad boy, which is?
Lithium aluminum hydride.
Outstanding. They're all sources of what? They're all sources of hydride, H-, which do nucleophilic attack on the carbonyls, yes?
Yes.
Just like the green yard. Okay.
Williams.
Williams on ether synthesis. You guys thought you were done? Or my dead body? He goes on everything. Run.
Kill him.
We're gonna finish. Let's say I have this. And how do I make this? From what do I make this? I make this from an alcohol. Okay, and adding what to the alcohol? A base. Okay, so I add a base to that alcohol and I get this. Let's say I have this, I add this to it, What is the product? Okay, let's not do it like this. Let's say I add that to that, what do I get? Now this stuff looks like what we did before, yes? Does this look like something we did before?
Yeah.
This is a nucleophile, and that is a primary
Accumulate.
What this is going to do is nucleophilic attack. And what is it going to do? It is going to substitute the BR with inversion of configuration if it is SN2. Yes or no?
Yeah.
And this is, which you have already done before, yes?
CH2,
BR. This is an ether. And you didn't know this when we did nucleophilic substitution before. Okay, SN1 and SN2, but that was called the Williamson ether synthesis. You got to know the name of it. The alkyl halides that you use for this synthesis cannot be tertiary, because if you add a tertiary alkyl halide to this, this will act like a base, and it's going to give you an elimination reaction. So I don't want you to go crazy, okay? Small this, small that, okay? Hello? Let's do Batman. Where are you going, La Vista?
Got a pee. Got a pee pee.
Is what? He is consistent at least, yes? It's bad not being able to hold your bodily functions.
Ooh, he's healthy.
It's actually
Not
It's actually
bad.
bad too, healthy.
It's not bad. It's healthy.
Being all the time is healthy?
Yeah.
That's called incontinence.
No,
It's called hydration.
it's called hydration. Yeah. He's well hydrated.
Now what do you use that for?
To cleanse your
Cells. Your cellular.
Okay, there it is. It's Batman. So, I'm going to tell you what you get from there is when the HBr is added to that, what happens first?
That's gonna take the.
It is going to protonate the oxygen. The oxygen, yes?
Yeah.
Once it gets protonated, now it becomes a better leaving group, yes?
Yeah.
Now there is a Br minus,
Yeah.
and the Br minus is going to attack this carbon, and that is going to leave as an alcohol, yes?
Okay.
If that happens again, where this OH gets protonated, then the Br minus attacks that again, and then that leaves as water. And then I have two of these, bromine here, bromine there. You write the product. See how you feel about that.
Okay.
You feel very sad? I feel sadder that I'm going to have to hand out so many outstanding grades. Okay, so here's what it is, yes? I will cut this here. I will put a BR. And if I do it on the other side, they're symmetrical, yes?
Yeah.
So I get two of these. Okay, and of course you need two of these.
It's very nice.
Is that 2HI?
What?
Is that 2HI?
Yes, it is 2HI. It is all the HIs you want. X's. Let's say X's. Let's not even say 2. You like everything in excess, don't you? Vista, what's up, man? People here be saying you got prostate problems. You still can get them. What you be doing with your prostate? Okay, guys, what's gonna happen is instead of the oxygen, I am going to place in its place. I am going to put a what? An I. So there it is. I'm going to place an I. It's on both sides. Okay. So it is 2 of those. 2 of those. Let's see our famous notes. We did that. We have epoxides. You know, I forgot to do before a reaction. You want to do it now?
What do you mean, what reaction?
I forgot to do one of the reactions that are important. Do you want to do it now?
Sure.
Is it on the test?
Of course it's going to be on the test.
Well, what is it going to be on? Like, I mean, which one is it? Is it on here or no?
Is it on where?
On this paper?
Which paper?
The handout.
Gave us?
No, it's not on that paper.
Oh.
Okay, that's called a vicinal dihalide. Okay. If I treat this vicinal dihalide with a strong base, there is going to be one elimination. So the Br and this H is going to leave, and it's going to have another vinyl. It's going to have a. Okay. You don't like it when I talk. You just like it when I show you, right? Is that what you like? Show you the money.
Show your work.
Okay? Is that okay? And this is called a vinyl bromide, yes? It's vinyl because the bromine is on the carbon.
The double bond.
And then what happens is the base again,
Okay. Strong base.
the base again pulls this proton off, and what it forms is an
A
alkyne.
triple bond.
So, vicinal, write it down in words. Vicinal dihalides undergo double elimination to form alkynes. I should have talked about this before, but I didn't. Guys, before we leave today, you gotta tell me what's gonna be on the test.
Everything.
Okay?
Would that be considered E2?
Yes, those would be E2.
Because there's
Okay,
It's a strong base.
so, how did we make an epoxide before?
Baby.
And what else?
H3O.
No?
Oh, wait, actually, no. Wait.
no.
You do not, you only know that MCPBA makes an epoxide, but you don't know what you have to start with.
But the, now you start with the dot.
Huh?
Start with an alkene.
An alkene, yes?
Yeah.
Okay, very nice. You start with an alkene, MCPBA, gives you
People.
an epoxide. This is syn addition, yes? Will be on the same site. That's an epoxide. You can also make an epoxide.
People.
Let's say you have that. And if you add a base to this, of course, you add that base, it has to be in water. It can't be this. Ionic compound, I don't have to solve anything else. what is going to happen, tell me? What do you think? If I add a base to this, what's gonna happen?
It's gonna abstract it.
It's gonna take the proton.
It's gonna take the proton.
Okay? There could be an elimination, yeah, you're right. But it's gonna abstract this proton here. If it abstracts this proton here, what it's going to form is this. O with a
Negative.
negative charge. And the Cl here. Okay? And this negative charge does something called an intramolecular nucleophilic attack on this carbon. So this oxygen is going to attack this carbon, and the chlorine is going to leave. And when it does that, it forms the epoxide. Okay?
What happened?
Hmm? What happened to what? You can ask.
I was gonna ask where the methyl group went, but I realized that it just went down.
Yeah, it's there. Okay, guys? You like that? You don't? Let's do some reactions of this epoxide, and then let's go into IR and mass spec.
Oh?
Very good for you, okay? So, okay, now let's start simple. You like it simple first. So let's say this is CH2 and this is CH2. That's an epoxide, yes?
Epo.
And let's say I add to this epoxide
My best.
some business like this.
That's a pretty big business.
And what happens? What happens?
Track.
The nucleophile is going to attack,
Yeah.
just like in the halohydrin, yes?
Mm-hmm.
In the halohydrin, the Cl minus made this attack. Now, if you have the epoxide and you add a nucleophile of any type, it is going to attack either here or there. Most of the time, the attack, depending on the temperature, depending on a whole bunch of things, all I care about is that you know the attack will occur faster at the less hindered carbon. And the product you are going to give me is at the less hindered carbon. Not at the most stable one, which is the more substituted one, but at the less hindered, because it is about the speed, not about the stability. Okay? Hello? So, what this is going to do is, it will attack here, and what else?
It's gonna
That's gonna break.
go to
And it's gonna go that way. And what you are going to form is, the O minus there, this is CH2, this is a CH2 with the OCH3. And of course, if you add water to this, what is going to happen is,
It's gonna abstract that.
it is going to protonate that,
Yeah.
and what you are going to have is
An alcohol.
an alcohol and an ether. How's that?
Well, we see.
All of these reactions for next week, you're sure?
No, of course not.
You're not?
We have all the activities purposes.
You have other classes?
Of course.
And other examples.
Sorry.
I have other things to do too, and yet you're reading a book. What do you mean? I read your book.
Yeah, he was up there.
Provide the product. Let's say, not in the first step, this step is water or whatever, an alcohol, an acid. What's the product?
Alcohol on
An alcohol on one side, yes.
on either,
An alcohol on one side, carbon
yeah,
with two hydrogens,
yeah.
carbon with two hydrogens,
And
sulfur
sulfur.
with a CH3.
CH3, yeah.
Where is it going to be the attack?
On the
On
left
the-
side.
on the
right.
On the right side.
At the less hindered
Hindered,
part.
next
Yeah,
less
the right.
hindered,
So
right,
the attack will be here.
right.
Yeah.
So the alcohol will open up that way.
Uh-huh.
The alcohol will be here on this carbon. So I'm going to say alcohol there,
Less hindered.
then this, yes, and then this sulfur with the CH3. Is that what you have?
Yeah.
How are you guys feeling today? So tell me, what would you like on the test? You can turn this thing on.
Turn it off.